So yesterday we had seen colligative properties, right? So the remaining colligative properties we were discussing. So what are colligative properties we have seen? Okay, colligative properties. So the four important colligative properties we have seen: lowering, relative lowering vapor pressure, elevation in boiling point, compression in freezing point, and osmotic pressure. So based on that, we have the equation, okay, to calculate the molecular mass of the solute, okay, present in the given solution. So these are the colligative properties which we have dealt mainly. Then we are discussing about what is osmotic pressure. Okay, first we have seen what is osmosis. So the first we have seen is what is osmosis. Can anyone tell me what is osmosis? Yes, can anyone tell me what is osmosis? What do you mean by osmosis?
The phenomenon in which flow of the solvent molecule from dilute
Okay.
solution to concentric solution through
Okay.
membrane, through
Semi-permeable membrane.
semi-permeable membrane.
Yes, so that is your osmosis. Okay. So then we are discuss about what is osmotic pressure. What do you mean by osmotic pressure?
The phenomenon in which flow of solvent molecule through
Yes, others. Okay.
membrane
Hmm.
from pure solvent to solution.
Okay. So what you are doing? Pressure. So we are applying a pressure, right? We are applying pressure on the solution side, right? So the flow of solvent molecules from the solvent into the solution through this semi-permeable membrane. So how this flow can be stopped? So this flow can be stopped. Okay, the flow of passage of the solvent molecules okay, into the solution through this semi-permeable membrane, it can be stopped by putting extra pressure, okay, on the solution side. So this pressure which stops the osmosis, it is called as what? Osmotic pressure. Okay, it is called as osmotic pressure. So this you can see the external pressure. Okay, the external pressure.
Applied on high concentration, ma'am.
Yes, that is only higher concentration means okay, higher concentration means on your solution side. So what you are doing, you are applying the external pressure. Okay, you are applying a high pressure so that whatever the solvent molecules are to be flowed, so that will be stopped to the semi-permeable membrane. Okay, so the excess pressure, extra pressure, okay, high pressure. So it is applied on the higher concentration side so that the osmosis, whatever the osmosis phenomena is taking place, it can be stopped. So this external pressure, okay, osmotic pressure, it is denoted by the symbol pi. Okay. Then we had discussed based on the osmosis, osmotic pressure. Okay. Then we have seen three types of solution. Okay. Hypertonic, hypotonic, and isotonic. Can anyone tell me what is isotonic solutions? What do you mean by isotonic solutions? So these are very important in terms of definition. Okay. Osmosis, osmotic pressure, isotonic solution, hypertonic solution, then hypertonic, hypotonic solution. Okay, with examples and reverse osmosis. So these are some of the important terms which can be asked in terms of definition for 2 marks. Okay, so 1 mark for the definition, 1 mark for the example. Okay, can anyone tell me what is isotonic solutions? Others can also try. Okay, Pavitra has to answer. Okay, answer.
If its osmotic pressure in higher than that of solution.
No.
Two solutions are isotonic if they exert the same osmotic pressure. These solutions have same molar concentration of 0.91%. Solution of a pure NaCl is isotonic with human RBCs.
Okay, so you have told this definition itself. Okay, in your own words, you can tell me. Anybody? So whenever the solution, so we have seen this particular diagram. Okay, here you can see. So whenever the two solutions, if you're comparing two solutions and their osmotic pressure is same. Okay, if they have same osmotic pressure is nothing but what it is. It is osmotic pressure is nothing but your concentration. Okay, it is the concentration. So we are discussing concentration. So osmotic pressure, as we have seen, it is directly proportional to what? It is directly proportional to concentration. So if the two solutions, they are resembling or they are having same concentration, then they are said to be what? They are said to be isotonic solution. For example, if you have a 0.91% NaCl solution, okay, that is a saline solution. It is called as saline solution. So this saline solution, it is isotonic with the human RBCs. What is RBC? RBC is your red blood cell. Okay. So whatever the saline solution is there, that is 0.91%. So the saline solution, so its concentration, that is it is isotonic. The two solution, that is a human blood cell and the your NaCl, pure NaCl, that is your saline solution, it is isotonic. Both these solutions are having same osmotic pressure. Okay, so these are said to be iso. Iso means same. Okay, same concentration. Okay, same concentration. So both have same osmotic pressure. Okay, now what do you mean by hypertonic? Hypertonic means what? Okay, hypertonic means if, okay, if the osmotic pressure is higher that of the solution from which it is separated. So if you have two solutions, okay, then what is happening? So a solution which has higher osmotic pressure, if the osmotic pressure is higher, okay, then what will happen? So in the two solutions, one of the solution is having higher concentration than that of the other, then the solution is said to be hypertonic solution. Okay, it is said to be hypertonic. Hyper, okay, hyper means high. Okay, and hypotonic means what? If the osmotic pressure, okay, if the osmotic pressure of one of the solution is lower than that of the given solution, then it is called as hypotonic. Hypotonic means it is having lower concentration. Okay, it is having lower concentration, then it is said to be what? It is said to be hypotonic. So examples are very important. So in hypertonic, okay, if you are keeping the blood cells, if they are placed in the saline solution, if the normal saline solution, what is the concentration? It is 0.91. Okay, if the blood cells, they are placed in the saline solution, that is your NaCl solution, with the concentration more than 0.9%, if the concentration of the saline solution kept, okay, is more than 0.91%, then what will happen? The water will flow out of the cell. Okay, the water will flow out of the cell and the cell will start to collapse. Okay, because the concentration is higher, because the concentration of the NaCl solution is higher. So what will happen? The water will flow out. It will come out of the cell. Okay, and the cell will start to collapse. It will get shrink. Okay, it will get shrink. So this is called as, so this is an example of hypertonic solution. Now what is the example of hypotonic solution? Same. Okay, if I take the blood solution, if I take the RBC, that is a red blood cells. So if I place this red blood cells, okay, in the NaCl solution, in the saline solution, and its NaCl concentration is less than 0.91%. Okay, if the concentration of the NaCl solution is less than 0.91%, then what will happen? The water will flow into the cell. The water, what will happen? The water will go into the cell and the cell will swell. Okay, swelling takes place. Okay, the swelling will takes place. So these are the types of, so on the basis of osmotic pressure, so these are the three types of solution. Okay, very important. With examples you have to, so it is asked. Then we had seen what is abnormal molar mass. Okay, how it is given? It is given by Van 't Hoff factor I. Okay, that is normal molar mass by the abnormal molar mass. So in case of association, remember the value of I will be less than unity, and in case of dissociation, the value of I is greater than unity. So these all factors we have seen. Then we had started. So from this, as we have discussed, okay. So from this solution chapter, we will be getting problems from this colligative properties. Okay. So from colligative property, one fixed question will be asked. Okay. So for 3 marks. So problems on colligative property. So the first problem we have seen. So this was a problem based on elevation in boiling point. So now we'll start with the second problem. Okay. So 12.6 gram of non-volatile electrolyte is dissolved in 75 grams of water. The freezing point of this solution is 271.9 Kelvin. If molar depression constant is 1.86 Kelvin kg per mole, calculate the molar mass of solute. So freezing point of the pure water is given as 273.15 Kelvin. Okay. So this is the problem. So this is a question based on what? This is a question. It is based on what? It is based on your freezing point, depression in freezing point. Okay. So how will you solve this problem, particular problem? Yes, students, how will you solve this particular problem? What is the formula? Yes. How to solve this? So which is the formula which you are going to use here?
Freezing pointer.
Yes. Okay. So freezing, depression in freezing point. So that particular formula which we are going to use here. Okay. So how, so what all are the things which are given here? Yes. So 12.6 grams of a non-volatile electrolyte is dissolved, okay, in 75 grams of water. So what all is given? The weight of the solute is given. Just a second. Okay. So the weight of the solute is given, a non-electrolyte solute, okay, and it is dissolved in what? It is dissolved in 75%, 75 grams of water, okay. So the freezing point of this solution, so the freezing point of this solution is what? It is given as 271.9 Kelvin, okay. Then the molar depression constant is also given. The molar depression constant is what? It is 1.86 Kelvin kg per mole. You have to find out the molar mass of solute. So what all are the given things? I'll write it down here. Okay. So so this is given. So the freezing point is given, that is delta TF. So try to solve this. So this is the formula. Okay, MB is equals to 1000 into KF into WB, okay, upon WA into delta TF. So this particular formula we are going to use. Okay, this particular formula we are going to use and substitute. So what is your freezing point? So the depression in freezing point, that is your KF. So KF value is given as what? KF value So use this formula. So the weight of the solute is given as 12.6 grams. Okay. Then the molecular weight is, it is dissolved in 75 grams of water. Okay. So the weight of the solvent is given as 75 grams. Okay. Then the freezing point of the solution is given. Freezing point is given as delta TF, that is 271.9 Kelvin. Okay. Then the molar depression constant, it is Kf. So that is your 1.86 Kelvin kilograms per mole. You have to calculate the mass of the molecular mass of the solute. Okay. Then molecular weight of the solvent you can calculate. Molecular weight of the solvent given this you have to find out. So it is of water. So how will you put the values? So 1000, okay, into Kf is what? Kf is 1.86 into WB is what? 12.6. Okay, divided by what is WA? WA is 75. Okay, into delta TF is 271.9. So by this you can calculate the MB. So just see how much you are getting. So 1000 into 1.86 into 12.6. Okay, divided by 75 into 271.9. Yes. How much you all are getting? Just check. I hope you all are having now this. So just see what answer. So like this, you have to substitute and get the answer. Okay. So the units are very important. The unit should be gram per mole. Okay, units are very important. So for like this formulas, for the formula, you will get 1 mark. For the correct substitution, okay, and the steps, 1 mark. And for the answer with the correct units, 1 mark. Okay, so like this. Fine. Okay, so I hope you have understood. We will go for the next question. The boiling point of benzene is 353.23 Kelvin when 1.80 grams of a non-volatile solute was dissolved in 90 grams of benzene. The boiling point raised to 354.11 Kelvin. Calculate the molar mass of the solute. Okay, Kb. Calculate the molar mass of the solute. Okay, Kb for benzene is given as 2.53 Kelvin kg per mole. So use this. So the boiling point. So you have to use this formula. So which formula? So the boiling point of benzene. Okay, it is given. So what all are the things which are given here? Yes. So your W when 1.80. So this is the W2 is the mass of the solute, that is 1.80 grams. Okay. Then when 1.80 non-volatile solute was dissolved in. So W1 is the weight of the solvent is 90 grams. The boiling point. So what you have to calculate is you have to calculate the molar mass M2 of the solute. Okay. So your Kb is given, Kb value. Kb is what? Kb of the, this is given, it is 2.53 Kelvin kg per mole. Okay. Now we have to change, we have to see the calculate the difference in boiling point. So that is given as delta TB is equals to TB minus TB naught. So TB is what? It is 354.11 Kelvin. Okay, you can see the benzene boiling point was this, okay, and the boiling point was raised to this. So that this change you have to calculate. So 354 minus 353.23 Kelvin. So the change delta TB is how much? It will come to 0.88 Kelvin. So 0.88 Kelvin is delta TB. So this you have to calculate. Okay. Now use the formula. So you know the mass of the molar mass of the solute can be calculated as Kb into W2 into 1000. Okay. Divided by delta TB into W1. So now what is Kb? Kb is 2.53 into W2 is 1.80 into 1000 divided by delta TB is 0.88 into what is W1? W1 is 90. Okay, now you see calculate. What will be the answer? Yes, 57. The answer comes to, it comes to 57.5 gram per mole. Yes, it is correct. Yes, okay. So, yes, so this is the correct answer. Fine. Okay. In the previous question, okay, let me see. Calculate the molar mass. Okay, your, so the change in delta TF. Delta TF naught would be how much? 273.15 minus 271.9 Kelvin. 273.15 minus 271.9, 1.25. Okay. So that would be, what would be, then it would be MB is okay. Okay, first we'll solve this. We'll go back again to the previous question. Okay, so the answer is 57.5 gram per mole. Okay, 57.5 gram per mole. So for the formula, 1 mark, for the substitution, 1 mark, and for the answer with the correct units, 1 mark. Okay, so we'll see this one more time. Okay, this particular question. So we have seen. So weight of the solute, it is 12.6 gram. Weight of the solvent is 75 grams. Okay. Then what all is given? Molar depression constant, that is Kf. Okay, so Kf is given as 1.86 kilogram per mole. Then delta Tf is equals to Tf minus Tf naught. So it will be 270 pure minus, so it is 270 freezing point of pure water. 271.9 minus 273.15. So the change in delta TF. So the delta TF, it can be calculated as, okay, so this comes to, sorry, 73. 273.15 minus 271.9. So this comes to 1.25. So now after putting the values, so what was the formula? So MB is equals to 1000 into KF into WB divided by WA into delta TF. So 1000 into KF value is what? 1.86 into WB is 12.6. Then WA is 75 into delta TF is 1.25. Now you see, if now the answer is coming correct. 1.86 into 12.6. 36. Okay, fine. So just see what answer, whatever the answer you get, it should be in gram per mole. Okay, we'll go for the next question, the fourth one. 300 centimeter cube of an aqueous solution of a protein, it contains 2.12 grams of protein. The osmotic pressure of such a solution at 300 Kelvin is found to be 3.89 into 10 raised to minus 3 bar. Calculate the molar mass of the protein. So gas constant is given. So what all is given? Volume is given. Volume is 300 centimeter cube. Okay. So and then W2 mass of the solute is 2.12 grams. Then is your temperature given as 300 Kelvin. Okay. Then the osmotic pressure is given. Pi is equals to 3.89 into 10 raised to minus 3 bar. Okay. Then what you have to calculate? You have to calculate the molar mass of the solute. Okay. Then what is the molar mass can be calculated as what? It was, so you know that osmotic pressure is denoted by pi. So pi is equals to, so pi is equals to RT, CRT. Okay. Now what is concentration is nothing but number of moles upon the volume into R and T. So we have to calculate the number of moles. So number of moles is given as what? Number of moles is given mass. Okay, that is W2 upon M2 into VRT into pi. So after calculating, you get the M2 is equals to W2, okay, W2 RT by pi V. Right. So this formula you will get to calculate the molecular molar mass of the solute. So now you put the values. Now your volume is in centimeter cube. So this you have to calculate in liters. Okay, because volume is there. So it should be calculated in liters. So it will be 0.3 liters. So we have to calculate everything in liters now. So 0.3 liters. So now put the values. W2 is what? W2 is 2.12. I'll write it here, this side. So M2 is, what we get is M2 is equals to W2 RT by pi and V. So what is W2? W2 is 2.12 into what is R? R value is 0.0823. Okay, into temperature is 300 Kelvin into pi is what? Pi is 3.89 into 10 raised to minus 3 into what is volume? Volume is 0.3 liters. Now calculate this. What answer you will get? Just check. Yes. See what answer you are getting. Hmm. 448.51. Okay, 448.5. Okay, gram per mole. So this is the answer. Everybody else is also getting the same. Just check. So for the correct formula substitution, 1 mark. For formula, 1 mark, and for the answer with the units, 1. Is it clear? So we have solved. problem on each type, that is relative lowering, then elevation in boiling point, freezing point, and then we have seen on osmotic pressure. Okay, fine. So now we'll see some extra questions. Okay, next question is 18 grams of glucose is dissolved. Okay, it is dissolved in 1 kg of water. At what temperature will the solution boil at 1.013 bar? Kb for water is 0.52 Kelvin kg per mole. Now, I am not going to solve this. I'm just going to tell you the formula. Okay, so by using that formula, you're going to use. So this is what, this is the problem related to elevation and boiling point. Okay, so because here you can see the solution boils, right? So try to solve this. So what all things are given? So what all things are given? So 18 grams. Okay, so it is the number of moles of solute. So the number of moles of solute is given as the it is W2 is equals to 18 grams. It is dissolved in 1 kg of water. So the mass of the dissolved in 1 kg of water. So 1 kg is nothing but 1 kg of water. So at what temperature will the solution boil? At 1.013 bar Kb is given. So what all is given here? First, we have to calculate the molar mass. So molar mass of glucose is required here. Okay, molar mass of glucose. So what is glucose? Glucose is C6H12O6. So after calculating the molar mass, how much you'll get the molar mass? Just check. So C6, so 12 into 6 plus 12 into 1 plus 16 into 6. So it comes to 180 gram per mole. Okay. Now, first you have to calculate what? You have to calculate the number of moles. What you'll calculate? You will calculate the number of moles of glucose. So how do you calculate number of moles of glucose? Given weight upon the molecular weight. So given weight is what? 18 gram upon molecular weight is 180 grams. So this comes to gram per mole. This is gram. So gram cancels, then 180. So this will be 0.1 mole. Okay. So this is the answer. Then, so the molality. So what is the molality of the solution? The molality is given as what? So we have calculated the molality. So the molality of the solution is 0.1 mole per kg. Okay. Because if we, so we have found out the concentration. We have found out the concentration of the solution. So if you dissolve 18 grams of glucose in 1 kg of solvent, we will get this concentration, that is 0.1 mole per kg. Fine. Now we have to calculate the change in temperature. Okay, it is given as what? Delta TB. So as delta TB, you know that it is equal to Kb into M. So we have this formula. So how the change in temperature can be calculated? As TB minus TB naught is equals to, what is Kb value? Kb value is given as 0.52. Okay, and what is molality is 0.1. So the change in temperature, okay, is 0.052. Now TB is what? So TB will be equal to 0.052 plus TB naught. Okay. So boiling point of water. What is the boiling point of water? Is 100 degrees. So you know that. Okay. So TB naught is what? TB naught is the pure water. So what is the boiling point of water is 300 degrees Celsius. So when you convert 100 degrees Celsius into Kelvin, so it will be what? 100 plus 273, right? So 273. So it will be what? So 0.052 plus 373.15. So this will be 373.202 Kelvin. So this is the change in temperature at which the solution boils. Yes. Okay. So this should be the answer. So let me check one more time. So 373.15 plus 0.052. Okay. So 0.052, it will be 373.202 Kelvin. So this is the temperature, okay, of the solution at which it will boil. Is it clear? Yes. So like this, the question can be asked. So by using the formulas, we have to uh, find out the given things. Is it clear? Yes?
Yes, ma'am.
Okay. So let me go for the next question. So 1 gram of non-electrolyte solute is dissolved in 50 grams of benzene. Okay. It lowers the freezing point of benzene by 0.40 Kelvin. The freezing point depression constant of benzene is 5.12 Kelvin kg per mole. Find the molar mass of the solute. Okay, you have to find the molar mass of the solute. So delta TF is given. What is delta TF? Delta TF value is the freezing point of benzene is 0.40 K. Okay. Then the KF factor is given. KF is what? 5.12 Kelvin kg per mole. Okay. So you have to calculate the molar mass of the solute. Then molar, that is the W2 of the solute is given as 1 gram. Then weight of the, this is given, weight of the solute, solvent is given 50 grams of benzene. Okay. Now, how do you calculate? Put the values. So the formula is MB is equals to 1000. So this is of depression in freezing point. So KF into WB divided by WA into delta TF. So put the values 1000 into KF is 5.12 into WB is 50. WB is 50. Oh, 50.
One, ma'am.
WB is the way to, yes, so it is 1. Okay, this is not 50, this is 1 because WB is your solute. The value W is your 50 into delta TF is 0.40 Kelvin. Okay, now you do this. So 1000 into, okay, 1000 into 5.12 into 1. So this comes to 5120 divided by 50 into 0.40. So this is 20. So 5120 divided by 20. Okay, divided by 20, you will get 256 gram per mole. Is it so? Yes. Okay. Okay, what about others? Others have also got the same. Okay, good. So gram per mole is very important. Okay, the units are very important. So as I'm telling you, so when you're practicing the problems, so practice in such a way that you have to write the, so stepwise you have to write. Okay, so first you make sure that you write the given things. So what all are given, so that it will be easy for you while substitution. Okay, because in substitution you may get confused. Okay. So first write the given things, then you can use the formula. So for the proper formula, 1 mark, for the substitution, 1 mark, and for the correct answer with the units, 1 mark. So these are the 3 marks questions. Okay. Next. Okay, so now this is based on the concentration, expression of concentration. So I have taken a problem in which we are going to see molarity, and mole fraction all together. So this is a problem. So calculate the molarity, mole fraction of Ki if the density of 20% mass by mass of aqueous Ki solution is 1.202 gram per mole. Okay. This is mole, this is gram per mole. Gram per mole. Okay. Then atomic masses is given of potassium 39 unified mass and iodine is 127 unified mass. So what is molality? How do you calculate molarity and mole fraction? So what do you mean by molality? Molality is number of solute particles dissolved in 1 kg of solvent, right? Then how do you calculate the molarity? Number of moles of solute dissolved in 1 liter of solution, right? And what is mole fraction? How do you calculate mole fraction? Mole fraction is what? Mole fraction is your whenever you're calculating the mole fraction, so the number of components of one to the total number of components of all the component present, right? So here, how we are going to solve this now? So molality. So starting with molality, when we are discussing about molality, so let us start with molality now. So molality is expressed as small m. Okay, so 20%. So the given factor is 20% mass by mass Ki solution. Means what? What do you mean by this? It means 20 grams of Ki. Okay, 20 grams of Ki is dissolved in what? Mass by mass. We have seen mass percentage, right? It is dissolved in 80 grams of water. Okay, it is dissolved in 80 grams of water. So 80 gram can be converted into kg as 80 into 10 raised to minus 3 kg. So here itself you make this then. So molality, it can be calculated as number of moles of Ki, number of moles of Ki divided by, okay, mass of solvent in kg, okay. So what is number of moles of Ki? It is 20. Okay, so number of moles of Ki, it can be calculated what? Given mass upon molecular or molar mass, right? So given, so here number of moles can be calculated as given mass upon molar mass of Ki, okay, divided by the mass of solvent in kg, mass of solvent in kg. So now so we'll put the values. Given mass is what? It is 20. What is the molar mass? Molar mass is 39 plus 127. What it will come? Just see. 39 plus 127. It comes to 166. So 166 is the molar mass divided by what is the mass of the solvent in kg? It is 80 into 10 raised to minus 3. Okay. It is kg in kg. So now what will be the values? Just see how it will be. So what value we are getting? Just see. Zero point 0.1204 divided by 80. Okay, divided by 80. Divided by 80. It comes to 10 raised to minus 3. So it comes to, so if I divide only 0.1204 into 80, it comes to 0.001506. Okay. So it is 10 into 10 raised to minus into 10 raised to 3 because if you transfer above. So if I shift this decimal to right side, so it comes to 1.506 mole per kg. Okay, so this is the answer in moles. Everybody got the same? No, just see. .506 mole per kg. Yes, Shivaduni has answered it right. Yes, others? Okay, good. Okay, so like this, we have to calculate. So now we'll calculate for, yes, Suraya has also answered it right. Good. Okay, so now we'll calculate the molarity. Okay, now what do you mean by molarity? You know, well, molarity is, it is mass of, so molarity is, what is molarity? Molarity is number of moles of solute divided by volume of solution in liter. Okay. Now, here, what all things are given? Just see. So, these are the things. If density, so density is given, right? We want volume. So, volume of solution. How do you calculate volume of solution? So, density, how volume can be calculated? So, volume can be calculated as mass by density. Mass we know, density we know. So, we can calculate the volume. So, volume of solution. So, volume of solution can be calculated as mass of solution divided by density. Okay. Now, what is mass of solution? Your mass is how much? Mass is mass of the solution, total mass. Yes, 20%. So 20 grams plus 80 grams of solution. So it is 100. So the total mass of the solution is 100. What is the density? Density of the solution is 1.202 gram per mole. Okay. So calculate this now. 100 divided by 1.202. So it comes to 83.19 ml. Okay. So this is the volume. Volume is 83.19 ml. Now what we have to convert it into liters. Okay. So how we will convert it into liters? It will be 83.19 into 10 raised to minus 3 liter. Okay, just multiply it by 10 raised to minus 3. Now use this formula. So molarity is number of moles of solute. The number of moles of solute again, given mass upon molecular mass. So it is 20 divided by 166. And what is the volume of solution is 83.19 into 10 raised to minus 3 liters. So now you calculate the molarity and tell me. So again, 20 divided by 166, it comes to 0.1204. Just a second, I'll use another color. Okay. So 20 divided by 166 is 0.1204 divided by 83.19. Okay, into 10 raised to minus 3. So divided by 83.19. So it comes to 0.00144 into 10 raised to minus 3. So if I shift the decimal, the answer comes to 1.44 mole per liter. So everybody got the same? Just check. Okay. Yes, Suraya. Yes, correct. Good. So like this, you have to solve the problems. Okay. Okay, good. One more, we are left with what? Mole fraction. Now we'll calculate the third, that is mole fraction. Now we'll calculate the third one, that is mole fraction. Okay, mole fraction. So how mole fraction is given as? Mole fraction is number of moles. So first you have to calculate the number of moles. So number of moles of Ki. So number of moles of Ki. What are the number of moles of Ki? It is 20 grams divided by 166 gram per mole, right? So that is mole fraction of A is given as a number of moles of A upon number of moles of A plus B. So this is the mole fraction, how you can calculate. Now, similarly, if you want to calculate the number of, this is of solute. Now I have to calculate of solvent. What is the number of moles of solvent? That is water, number of moles of water, H2O. So given mass of the water is what? Water is 80 grams, right? Because 20% means 20 grams of solute dissolved in 80 grams of water. So 80 gram divided by what is the water? It is 18 gram per mole. So this is what and this is what, find out the value. So the value number of moles of this is 0.204 mole. And this how much it is coming, just see, gram get cancelled. This will be 4.44 mole. Are you getting the same? Just see number of moles. Yes, 4.44. Yes, good. Okay. So 4.44. Now, mole fraction of Ki, it can be calculated as number of moles of Ki upon number of moles of Ki plus number of moles of water. So Ki is 0.204 upon 2.4 plus 4.44. Okay. So just see how much you're getting. Mole fraction of Ki, the total, what is the answer? Yes, see what answer you're getting, 0.204 plus 4.44. So this comes to 4.644 and 2.204. So this is 0.204 plus 4.644. Yes, how much you're getting? It your answer should be 4.84. Sorry, your something else. Wait. 20 divided by 166. Sorry, here it will come. Make the correction. Your number of moles of Ki is 0.120. Okay, 0.120. So similarly, this also will change. So it is 0.120. 0.120. So here 0. This will change. So the value will change. So 0.120 plus 0.444. Right. Yes. So it comes to 4.56. 4.56. Now you do this. So 0.120 divided by 4.56. It comes to what? What will be the answer? The answer will be, yes, 0.0263. Everybody is getting the
Yes,
mole
ma'am.
option. Okay. Okay, many have answered. Yes, Srivaruni, Suraya, baby, then Suraya. Okay, okay, correct. Okay, so this is the correct answer. Fine. So like this, we have to solve the problem. So here in this chapter solutions, okay. So the concentration, okay, expressing the concentration in terms of mass percentage, volume percentage, mass by volume, molarity, mole fraction. So these problems are important, and the colligative properties problems are important. So from this part, the questions will be asked. Okay. So any doubts in solution chapter? So by this, we have completed the chapter solutions. Okay. So the first chapter, no, mole fraction does not have any unit. Okay. Mole fraction does not have unit. So you have to keep it like that only. Okay. So by this, we have completed the chapter solutions. So did you understand the chapter? Yes. Did you understood the chapter? Any doubts? Anything which you have not understood? Yes. So from tomorrow, we are going to start with the next chapter. Okay, we are going to start with the new chapter. So then we are going to start with the organic chapter, that is haloalkanes and haloarenes. Okay. Fine. So no doubts. Okay. Fine. So by tomorrow, from tomorrow, we are going to start with a new chapter, that is haloalkanes and haloarenes. So before coming for the class, I want you all to just read some introduction. Yes, I'll be sending the notes. Yes. Okay, I'll be sending the notes. So it will be sent in your groups. So please go through the notes also. Please revise it. Okay, keep studying. So it will be in touch with you. Okay, you won't get the things won't get okay. It will be, you have to just keep on studying a bit. Okay, so that it will help you. You won't forget the things soon. Okay, so just read the things whatever have been told. And for tomorrow, okay, I'm going to start with the next chapter, that is haloalkanes and haloarenes. So please read the introduction parts. Okay, you need to know what are haloalkanes, what are haloarenes. Okay, so these all things. So basic things, just read and fine. Okay then. So I shall end the session here. Okay, we will meet in the next class.